Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 16, Population Problems. Okay, classwork, opening exercise. So this is not going to be the same as me if you did this in your own classroom because every classroom is different. It says here students work with a partner to fill in information in the table. All right, so they also said to remind students that vowels are A, E, I, O, U, and sometimes Y if there's no other vowel in that word. Okay, so anyhow, I'm just going to make up values for this because I don't have a class to count right now. So let's say there were 15 girls in a class and 11 boys. Total number of students in class, 15 plus 11, 26. Percent of total number of students that are girls. Percent of girls is 15 out of the total 26. Okay, so here's my calculator. 15 divided by 26 equals 0.5769. Okay, so this was a percentage, I believe they're asking for. Percent of total number of students that are girls, so that would be 57.69%. Percent of the total number of students that are boys. Well, did I round that correctly, by the way? 692, yes. All right. Well, I could actually plug that in. It would be 11 over 26. But if there's 100% of the class is boys or girls and 57.69% are girls, then I can just take 100 minus this 57.69. And that'd be 0.31 to get to 58, and that would be 42. Now if I check that, and I put 11 divided by 26, I should get 42.31, and 7 rounds to 0 to 1. Percent of boys and girls in the classroom. Well, that would be boys and girls, so that'd be 15 plus 11 over 26, which equals 26 over 26, which equals 100%. Number of girls whose names start with a vowel. Okay, well, I'm not going to continue this because then I'd have to make up a roster. And, well, let me see. Okay, I decided to do this anyway. So what I did was I used old.wave39.com/roster/generate.php. So this was a roster generator website. And I generated a roster with 11 boys and 15 girls, and the numbers next to them. This was for a jersey. It was for a sporting team, and it assigned them a number on their team. So we'll disregard the numbers, but I just wanted to use this for the purpose of this assignment. So if I have, let me move this down a little. So it says number of girls whose names start with a vowel. So here are the girls down here. And I'm looking for names that start with A, E, I, O, and U, and there is 1. And that is it. So number of girls whose names start with a vowel, 1. Number of boys whose names start with a vowel, H, D, M, F, G, H, C, C, G, T, M, and that is 0. Number of students whose names start with a vowel, 1. Percent of girls whose names start with a vowel, 1 over 26. Then I go here and I go 1 divided by 26 equals 0.0384. So that is about 4%. About 8%. Percent of the boys whose names start with a vowel. Well, that's 0 out of 26. That one's easy. 0%. Percent of the total number of students who are girls whose names start with a vowel. Percent of girls. Oh, okay. Well, guess what? This goes down here. I read that wrong. My apologies. If you have already copied this, just draw arrows. All right. So now I'm going to answer these questions. So this is percent of the total number of girls, of students whose girls. Percent of girls whose names start with a vowel would be 1 out of the number of girls, which is 15. 1 out of 15. And that as a percent is 1 divided by 15 is 0.06 repeating. Okay, or that's about 7% when I round. Percent of boys whose names start with a vowel would be 0 out of 15, which is still 0%. Percent of students whose names start with a vowel. Well, that would be the same as here because there were no boys, so it's still 1 out of 26, which is approximately 8%, since there were no boys whose names started with a vowel. Okay, example 1 says, a school has 60% girls and 40% boys. If 20% of the girls wear glasses and 40% of the boys wear glasses, what percent of all students wear glasses? Okay, so let's let n equal number of students total. The number of girls is, okay, so girls would be represented as, using the letter N, girls would be 0.6 N. And boys would be 0.4 N. Because girls plus boys would equal 1 N, or 100% of the number of students. So if once I do that, what does this ask us to do anyway? What percent of the students wear glasses? So the number of girls wearing glasses is as follows. 20% of the girls. So that would be, let me change colors. So that would be 20% of this. So I would take 20%, which is 0.2. times the number of girls in the school, which is 60% of the total population. And that would equal 6 times 2 is 12, 2 decimal places, so that is 0.12 N. So 12% of the school's population are girls who wear glasses. Okay. Now, boys would be 40% of the boys wear glasses from this 40% of the population. So that would be 0.4. 40% of the boys wear glasses times 0.4 N. And actually, on this one here, let me move this down so I can erase this. The N should be inside the parentheses, not that it really matters. But I'm going to just stay consistent with both equations. So if I put the N here and the parenthesis outside here, it's still going to come out the same, but I just wanted it to have the N inside. All right, so now 0.4 times 0.4 is 0.16 N. So that means if 40% of the boys, which is 40% of the school, that is 16% of the population wears glasses. So the total number of students that wears glasses is 0.12 N plus 0.16 N, which equals 0.28 N, or 28%. Of the students. So it says, what percent of all students wear glasses? 28%. Okay, now it says, how does the percent of students who wear glasses change if the percent of girls and boys remains the same? That is, 60% are girls and 40% are boys. So girls is 0.6 N and boys would be represented by 0.4n again. But now it says 20% of the boys wears glasses and 40% of the girls wear glasses. So we switched them around. So now if it's 20% of the boys wear glasses, it's 0.2 times 0.4n, which equals 4 times 2 is 8, 0.08. And be careful with your decimal places. There are 2 decimal places. Okay, that is the boys. The girls would then be 40%, which is 0.4 of the 60%, which equals 0.24n. So if I take that 0.08n plus 0.24n, that is going to equal 0.31n, and that's the percent, so it would be 31%. So before we had 28% of the student population wears glasses, but with us just switching the percentages of the boys wearing glasses to girls and the ones that was girls to boys, then the percent went up from 28 to 31% needing glasses. Exercise 2. How would the percent of students who wear glasses change if the percent of girls 40% of the school and percent of the boys was 60% of the school and 40%? So this is just the same question. So now it's saying that the percent of girls is 40% of the school. So girls is now 0.4n and boys is 0.6n, and then 20% of the 40% of the girls wear glasses and 20% of the boys. So now we would have 0.4, 40% of the girls, and I'm just going to do this all at once, plus 20% of the boys. I don't need the 0, I suppose. 20% of the boys and I want to, in the total, the number that will come out in front of the n is going to be my percent. So 0.4 times 0.4 is 0.16n plus 0.2 times 0.6 is 0.12n, and 0.16 plus 0.12 is 0.28n, or 28%. And then it says why. Okay, so here's the why. The number of students wearing glasses would be equal to the answer, for example, 1, because all of the percents remain the same except that a swap is made between the boys and girls. So the number of boys wearing glasses is swapped with the number of girls, and the number of girls wearing glasses is swapped with the number of boys. But the total number of students wearing glasses is the same because multiplication and addition are commutative. Example 2. The weight of the first of 3 containers is 12% more than the second. Okay, so here we're going to have to identify 3 containers. So the weight of the first 3 containers is 12% more than the second. The weight of the first 3 containers is 12% more than the second. And the third container is 20% lighter than the second. So we're comparing everything to the second. Okay, so if we're going to compare everything to the second container, let's let x equal the second container. All right, so now we have a variable, and it would be the weight of the second container. Okay, we're talking about weight. Let x equal second container's weight. All right, so let me think about this. So here it says the weight of the first of 3 containers is 12% more than the second. So the second container is x. All right, the first container is going to be 12% more than the second container, which is 1.12 times the second container. And the third container is 20% lighter than the second. So if the second's 100%, 20% lighter than 100% is 80%. So I'm going to let the third container be 0.8x. So there's the first container, 12% more than the second. The third container is 8 or 20% less than or lighter than the second container. By what percent is the first container heavier than the third container? Okay. So all we have to do now is take 1.12x and subtract 0.80x. And when I do that, I get 0.32. By what percent is the first container heavier than the third? Okay, so if our second container weighed 100 pounds, the first container weighs 112 pounds. The third container weighs 80 pounds. So the difference in weight would be 32 pounds. It wants to know what the average, by what percent is the first container heavier than the third container. So what I need to do now is take their differences and divide by what the third container is. So if I take 0.32x and divide it by the third container, 80x, and I go to my calculator and I type in 0.32 divided by 0.8, then I get 40%, or 0.4. So the first container is heavier than the third container by 40%, or 1.4% times 100% is 140%, which also shows that the first container is 40% heavier. Okay, so let's check that. If we just use that example that I gave, 100 pounds, 80 pounds, 112 pounds, make it really easy. So if I took 80 pounds and multiplied it by 1.4, I should get 112. And there it is. So the first container is 40% heavier than the third container. Exercise 3. Matthew's pet dog is 7% heavier than Harrison's pet dog. And Janice's pet dog is 20% lighter than Harrison. So we're all comparing our dogs with Harrison. So let's H equal 100%, or actually weight of Harrison's dog first. Let's let Matthew's dog, M, equal 70% heavier than Harrison, so that would be 1.7H. And then Matthew's dog, and then wait, we have who else? Matthew's pet dog is 7% heavier, not 77, 1.07 of the weight of Harrison's dog. And Janice's pet dog is 20% lighter than Harrison, so that'd be 0.8 of Harrison's dog. By what percent is Matthew's dog heavier than Janice's? So from that last example, you should be able to do this. If we let H equal 100%, or just H, then we want to know what percent Matthew's dog is heavier than Janice's. So we take 107H minus 0.80H, and we get 7.2, and we get 0.27H. 0.27. So then I take that 0.27. Now remember what we did back here. Once we got our answer, we divided it by what percent is the first container heavier than the third. So the third container is what we're dividing by. We take the difference and divide by the third. So I subtract and I get the difference between Matthew's dog and Janice's dog, and then I take 0.27h, the difference, and divide it by what Janice's was, which was 0.8h. So if I take 0.27 divided by 0.8, I get 0.3375. Which is 33.75%. Okay. So Matthew's dog is 33.75% heavier than Janice's dog. Okay, so example 3 says, in 1 year's time, 20% of Miss McElroy's investments increased by 5%. 30% of her investments decreased by 5%, and 50% of her investments increased by 3%. By what percent did the total of her investments increase? So she has 3 investments. So she has 20% increase by 5, 30% increase by 5, and 50% increase by 3. So 50, 60, 70, and 30 is 100%. Oh, that's a decrease by 5. 30% decrease by 5. Got to be careful there. Okay, so let's let N be original investment. Okay, so we're going to let N equal the original investment. So after the changes, here's what we're going to have. We're going to have 20% increase by 5%. So 20% as a decimal, 0.2. 20% of her investment increased by 5%. So I multiply that by 1.05. That's 5% increase. And then we're going to add that to 30% of her investment, or 0.3N, decreased by 5%. Well, 5% less than 100% is 95%. So we're going to multiply that by 0.95%. And then we're going to add 50% of her investment, 0.5N, increased by 3%, 1.03. So when I multiply all of this, 2 times 5 is 10. And there's 1, 2, 3 decimal places, so it's 0.210. So 0.210, I don't need that 0 at the end. And don't forget your N. So 0.21N plus 3 times 5 is 15. 9 times 3 is 27, plus 1 is 28, and 1, 2, 3 decimal places. So this would be 0.285N plus 5 times 3 is 15, 5 times 1 is 5, 3 decimal places, plus 0.515N. When I add these all up, I have 3 decimal places, 3 decimal places, 2 decimal places. So 5 plus 5 is 10, carry the 1. 2, 10, 11, carry the 1. 5, 6, 7, 8, 9, 10. Okay, so it's 0.2 plus 0.2 plus 0.5, which is 1.01. I don't need that last 0. So it's N, 1.01 of her total investment. So what does that mean? 20% increase by 5, 30% decrease by 5, that hurt her, and 50% increase by 3. So her total portfolio increased by 1%. So if she had $10,000 in her investment, now she has 1% of 10,000 or 100, so $10,100. Exercise 4. A concert has 6,000 audience members in attendance on the first night and the same on the second night. On the first night, the concert exceeded expected attendance by 20%. Okay, that was the first night. While the second night was below the expected attendance by 20%. So they expected more to go the second night. So maybe the first night was a Thursday and the second was a Friday. So since it's the weekend, more went. So the second night was below expected attendance by 20%. What was the difference in percent of concert attendees and expected attendees for both nights combined? So first we have to let's let X represent the expected number of attendees first night and we will let Y equal expected night 2, second night. Okay, so the first night, let's go back to red. They expected, what is it? On the first night, the concert exceeded expected attendance by 20%. So first night, we can say that the expected attendance was exceeded by 20%, and that equals 6,000. And on the second night, we could say Y plus, and then it was the concert exceeded expected attendance on the second night was below the expected attendance by 20%. So if it's below, we want to subtract, not add. So it's going to be the attendance that was actually there minus 20% of the expected, which equals 6,000. Now I'm going to simplify these and solve for x. So 1x, that's a 1 there. Hello, I said red. That's a 1 there. 1x plus 0.2x is 1.2x equals 6,000. Okay, and then when I divide both sides by 1.2, I know 12 goes into 65 times, so 1.2 would go into 6,000 5,000 times. Okay, so the first night was attended by 1,000 people more than expected. The concert had 6,000 in attendance, and the same the second night. The first night, the concert exceeded expected attendance by 20,000, or by 20%. Okay, so this was their expected. X equals the expected attendance, night 1, 5,000, and they actually had 6,000. So it says, what was the difference in percent of concert attendees, expected attendees for both nights combined? Okay, so now we want to do the second night. Well, y minus 0.2y is 0.8y equals 6,000. Divide both sides by 0.8, and y equals hello, 6,000 divided by 0.8. 7,500. So they expected 7,500 to attend the second night, but only 6,000 did. So they were over by 1,000 one night, and then under their expectations by 1,500 the second night. So now what we do is we take the differences. So this was 1,500 was the expected, over of the expected. Let me see how I could word this. The second night was attended by 1,500 less than expected. So if I took the total here, 5,000 were expected the first night, 7,500 were expected the second night. So they expected a total of 12,500 attendees for the 2 nights. Well, there were 6,000 and 6,000, which was a total of 12,000. So they were down by 500. We want to know what that percent is, because it says what was the difference in percent of concert attendees, expected attendees, and expected attendees for both nights combined. All right, so where were we? The second night was attended by 1,500 less than expected. That's right here. So if I take that 1,500 and subtract 1,000, and then 1,000 is coming from here. They expected 5,000 but got 6,000 attendees. They expected 7,500 but got 6,000, so there was 1,500 discrepancy here and 1,000 here. So when I subtract those, I get 500. And that's the difference. One was over, one was under. This was 1,500 under, this was 1,000 over, so they were under by 500 total. So we take that 500 and divide it by the total that we had, 1,000 or 12,500. So we're taking the difference of the 2 nights. One was 1,500 over, one was 1,000 over, one was 1,500 under. That's a difference of 500. And then we divide that by the 12,500, the total attendees, the 2 nights expected. And when I divide these and multiply by 100%, okay, I'm doing the formula here with the difference divided by the total times 100%. And if the zeros cancel and these zeros cancel, 5 goes into 12 2 times. 5 goes into 25. So that's 1/25 times 100%. Well, a 25th is, how many times does 25 go into 100? 4. So it's 4%. So the concert missed its expected attendance by 4%. Okay, that is the end of lesson 16. Review the lesson summary and go do your problem.